Hello, so the purpose of this video is to show you how to get the rocket game working. This rocket game will use functions that we've learned from every kind of unit that we worked through so far this year. So starting, go grab the text file. Make sure you save yourself a copy before you begin. So I have the text file open. I'll save myself a copy. And I'll call this Rocket Lander video. So we have it to work from. All right. So right from the beginning, you can hit the run button. But when you do, what you'll realize is that nothing happens. The rocket will just sit there in the sky in the Rocket Lander game. Not much of a fun game. No rocket falling or doing anything as it goes towards the surface of Mars. But let's get it moving. The first way we're going to get it moving is we're going to get it moving horizontally across the screen, which is it's going to do at constant velocity. So that was our key idea in our constant velocity unit 2. So if I go down here to unit 2, I've done some of the work for you, and you have additional instructions to work with. So I provide you the function, but I have the note that says add a contract, purpose, and examples. So that's what I'm going to do. What's written above will help you too. So notice it says add your 2-argument next x function along with its contract and examples. Then in the make lander function at the end of the code, change default x to next x. That's what I'll do. So let me write the contract first. If I look at the function, notice it takes in 2 values. It takes in current position x and velocity v. So it's going to look like this. Next x number, taking in both those numbers and producing another number, which is going to be the next x, the next position across the screen. I'll write some examples. With what I need for examples here are just to satisfy that there are numbers producing a number. So let's say we have a position of 100 and a velocity of 10. I want the computer to do 100 plus 10 times delta t. Sorry, one more. Next x. Let's throw another position. Let's say 400. Let's say this time the rocket's going 25 meters per second is 400 plus 25 times delta t. Okay, and then I will end my example section. Before I run it again, this is an important step. Whenever I complete, like let's say missing purpose. Let me do that first. The purpose of this function is to consume current position and velocity and produce next position. Now, with contract, purpose, and examples, along with the function I provided to you, we now go to the bottom of the code, and next to next x way at the bottom, we move the default dash. That will get it so it uses your next x function that you just produced, not the one that's running in the background. And then I'll hit run. And it should go across the screen now, moving horizontally. But you'll notice that you'll eventually run into a problem. And the problem is this. At a position of 800, it will leave the screen and just keep going, and you won't be able to see it anymore. So we're going to deal with that problem next. Let me close that. Notice my examples still pass, so I'm good there. Notice I've written some examples already. That's why you have a lot more there than just for the next x function. Now, as I continue below, to keep it running from the start, I'd add some hashtagging here. So on line 57, I'm going to remove the hashtag and the line. And then from line 70, I'm going to remove that line and hashtag too. That will get this next part of the function active again, which looks at if it's on screen, meaning that can you see the rocket or you can't see the rocket. It has instructions above here that are helpful. It says your lander has probably drifted across the window and off the right side of the screen. Design a function called isOnScreenX, which consumes the lander's current X position and returns true whenever the lander's current X position is actually visible on screen. Then, again, go and remove the default at the bottom. And I've said add a purpose and one more example for each outcome. Now let's do that. So we have the purpose. The purpose of this function is to consume current X position and produce true when the rocket is on screen. Then I'll add one more example. Note the function is just that isOnScreenX is when X is greater than 0. That's the first part. And then if you look at the second part of the function, X is less than 800. So it's on screen when you're above a 0 position, but less than 800 position. That's why my first example works of a value of 10. What's another number that could work? Well, I could do 200 because 200 is also between 0 and 800. Okay, and I'll write another example for false. Is on screen X, let's say 2000, because I know 2000 is above 800. All right, those should be good. Let me go to the bottom. Remove the word default next to isOnScreenX. And I'll hit run. Oh, I have some spaces that I have to fix. Yep, no space between function name and my example. Fix that. There we go. And what we should notice this time is when the rocket reaches that 800 point and that statement becomes false, it's going to loop the rocket back to the beginning for us so that we'll eventually be able to keep playing the game. Loops right back. So we're good to go there. Along the way, definitely hit the save button when you've accomplished certain tasks so you have that saved copy. We move down to Unit 3. In Unit 3, we actually worked with two functions. We worked with the function when you're accelerating to be able to produce next position, and a function when you're accelerating to produce next velocity. I have those functions in there already. All we need to do is write the contract and examples. I actually already have the purpose for you. So for example, this one would be next y, which takes in a number, which is current position, and another number, which is average velocity in the y, and produces a number next y position. Examples. I can choose any y positions I want. Will work. Let's say my y position is 100 and my y velocity is 10. And I just plug them into the right spot following my function. I'll leave delta t as delta t because what delta t is actually hidden away from you in the background code. Just writing my second example. Remember, you can choose whatever numbers you want here. And I will end my function section. Let me do next Vy. Which is once again taking in a number and a number and producing another number. And write my examples. And then I'll plug in a velocity again. Whatever velocity you want will work. Whatever number for g, which in this case is using the acceleration due to gravity on Mars in the background. But we can use any value we want. These are just examples. All right, so for each of those now I have a contract, followed by a purpose, followed by examples. Oh, let me make sure I end this. Followed by my function. Now I'll go to the bottom and remove the defaults from next y and next Vy. And I'll hit run. Now what you're going to notice is that as it goes, it will also fall. So it's moving at constant velocity horizontally, and it's accelerating vertically to that ground. Once again, if we want to, hit save. Now, the next function, which is game status, I've already done for you. This will just change the word at the top of the screen. So instead of when you hit the ground, it still says flying, it will respond either back safely landed or crash landed. The key difference is this. If you look at how this conditional is written, it will only safely land if the essentially vertical velocity is less than a magnitude of 10 coming in. Because any faster than that, you're going to get a crash landing. So the only thing I need to do here is, because I've done the code for you, is find game status, remove the word default. And I'll hit run again. Now you're going to see that it's flying. Notice my Vy is like negative 20 something right here. And eventually it's going to hit the ground, which it will say crash landed. The reason being Vy is equal to negative 54.552. And this is in meters per second. This would mean that it's hitting around over 100 miles per hour, which would not be good for any rocket. So we'll get that to go slower in the future by adding some thrust for the rocket. So let me close that. and move to the next unit. So I'm now on unit 5, which we're going to get into forces. And it says add a contract and examples. So it says define a function called sum of forces that consumes the rocket's thrust and produces the total force of the rocket due to both the thrust and the gravitational field. Then again, remove the default. But if I look at the function, notice it's only really inputting what we're going to call thrust. Its mass and what's called GFS, which is the acceleration due to gravity on Mars, will be identifiers that you're going to see at the top. So we don't have to have that as an input in our contract. So it's just going to input a number and produce another number, which is that sum of forces. I'll write some examples. Following the rule that the thrust essentially just needs to be a number. Let's make it 100. I'm not going to plug in numbers for identifiers so that it uses the numbers above that you'll find at the top. Only adjusting thrust inside my examples. Again, remove sum of forces. I can certainly hit run. Oh. Got a mistake. Oh, yep. Just the function name. There we go. My bad on that one. You won't notice much of a difference yet, though, because we can't control the thrust yet. And that will be the final part that we do. It is, once again, going to crash land. Now, I have... Go to the bottom. We have another function, and this is essentially Newton's second law. Taking acceleration from our sum of forces. It tells me to add a contract, purpose, and examples. So I'll start with my contract, which it takes in the sum F number, which is using the number from the above function, a number, and producing another number, which is the acceleration of our rocket. The purpose of this function is to consume the sum of forces and produce acceleration. Write some examples. Let's say the sum of forces is 0. Again, leaving the word mass because mass is identified above. Let's say the sum of forces is 15. And that. I got my contract, I got my purpose, I got my examples, and I have the function I've done for you. Go to the bottom. Remove the default from A from F. And hit run again. And once again, you're going to realize that can't really do anything yet because there's no thrust. So any equation that we've built in the last two really doesn't do much when there's no thrust yet and no way to control it. Last step is to control the rocket, and I've kind of done this one for you. All you need to do, as I state here, is remove the word default. Okay, from thrust with key. Now notice we have no defaults left anymore. And I've passed all my examples that I've gone through, and I can hit run. And now when I do, if I hit the up key, it will produce a thrust, and it lists you the thrust on the screen. Down key produces a thrust. And I didn't start mine fast enough. Notice I still crash land. The reason I crash land is when I landed, my Vy velocity was still negative 37.388. I need to get that between 0 and negative 10. So let me see if I can get it for you. I'll try one more try at it. You'll get good at it as you keep playing. Let me slow it down. Oh, way off. I can actually slow it down from beginning with. Then I'll be able to get some control of the rocket. Notice my sum of forces is 0 here. Notice how my velocity is not changing, but I'm still headed down. It's going to come back on screen, and I will slow it down one more step, and this should land it just perfect. Oh! Oh, still crash landed it. Almost there. Try it one more time. Okay, let me start slowing it down. Oh, need to thrust down again. Oh, I'll get it again. This will eventually work. This is kind of a trick. If I get it so that I'm falling, but now I'm falling at constant velocity due to balances of the forces, I should eventually hit the ground safely. Safely landed, and there we go. So if you look back at the assignment, there's a number of things I have you screenshot, including this picture, which shows that you safely landed the rocket. When you get back here, I have you screenshot showing me that all